Alrighty, in question number 21, it asks for the measure of angle P in this figure shown. Well, this figure shown is an isosceles triangle. An isosceles triangle. And I know that because it shows me that I have two congruent sides, right here and right here. MP and NP are congruent sides. So what that means is that MP is my base. And because I have two congruent sides, I also have two congruent base angles. So angle M is 66 degrees, and angle N is also 66 degrees. So you guys are really, really smart, and you know that three angles in a triangle add up to 180 degrees. Well, I know that one of the angles is 66, the other angle is 66, and angle P is, we don't know, so we'll call it X. So I can write an equation that says 66 plus another 66 plus the missing angle X is equal to 180. And then I can solve that equation by combining my like terms. 132 plus X equals 180, and then subtracting 132. So the missing angle was equal to, looks like 48 degrees. Number 22, it says to locate the blank of a triangle, you can construct the medians. So I know if I construct the medians of a triangle, it's going to give me the centroid. Centroid is also the center of gravity for the triangle. In class, we made these triangles, and then we balanced them on our finger. Pretend that's a finger. It's like wrinkles on a finger. I don't know. Anywho, number 23, to locate the blank of a triangle, you can construct the perpendicular bisectors. So if I construct the perpendicular bisectors, that's going to give me the circumcenter. We learned that the circumcenter is not only the perpendicular bisector's meeting place, it's perpendicular bisector, perpendicular bisector, perpendicular bisector. So it's not only where the perpendicular bisectors meet up, but it would also be the center of a circle circumscribed around that triangle. Number 24 says list the angles in order from the smallest to largest. I know that the smallest angle is opposite the smallest side. So if 4 is the smallest side, then across from that 4 will be the smallest angle, angle C. So angle C is the smallest, therefore C is the best answer. I know that 5 would be the next smallest, that would be the second smallest, so therefore the angle across from that, angle A, would be the second smallest angle. And then 6 is the biggest side, so therefore angle B would be the big angle. So C is the best. Question 25 says that each side of the square is 80 units. So this side is 80 units, and this side is 80 units, and that side is 80. They're all 80 units, and it's a square, so I know that these are right angles. It asks for this missing length. So you can see that it makes a right triangle. The diagonal of that square makes a right triangle. So I'm going to label this A, I'm going to label this B, and this side will be labeled C because it's across from the right angle. So Pythagorean Theorem says A squared plus B squared equals C squared. And A is 80, and B is 80, and C is I don't know. So I'll have to square these. Oh man, 80 squared would be 6,400 plus 6,400 equals X squared. Alright, combine those terms and you'll get 12,800 equals X squared, and then we'll have to square root both sides. Cool, this is going to be a kind of a big number to break down, but we can still do it. I know that 100 goes into it 128 times. See, because I know that the square root of 100 is 10, remember we're looking for doubles. I know they're not prime numbers, but I'm not trying to do a ton of work, so I'm just going to stop here at 10 because I see doubles. I don't usually do that, but this one's such a big number, And then 128, I can break that down to be, what, 2 and 64? And 64 I know is 8 and 8. So again, I'm going to, because it's such a big number, I'm going to stop there. So I know that that number could be the same thing as saying 10 times 10 times 2 times 8 times 8. So I notice that I have doubles of the 10, so that can come to the outside. I also have doubles of the 8, so that can come to the outside. Oops. And then the 2 has no friends, so he stays inside. So 8 times 10 is 80, radical 2, and that's where we'll stop. So the best answer choice is C. Right. On number 26, I think this is a messed up. Oh no, this is a good question. Good question. It says that DE is 7. It says that EF is 12. What could be the missing length of DF? So I'll put an X here for DF, and I know that the smaller two sides have to add up to be more than the third, otherwise it won't come together to form a triangle. So I know that 7 plus 12 has to be greater than X if X is the biggest side. But maybe X isn't the biggest side. Maybe X is the smallest side, and 12 is the biggest side. So then the inequality would look like X plus 7 is greater than 12. So there's my two different possibilities. So if I simplify a little bit, I can be like, hey, that'd be like 19 is greater than X. So I would look for X values less than 19. And then over here, I'd be like, okay, well, I could subtract 7 on both sides, and I know that X would have to be greater than 5. So I'm looking for a range of X values between 5 and 19. So 24 is not between 5 and 19. 19 is not between 5 and 19. 10 is between 5 and 19, and 5 is not. So 5 is the only possibility that would fall in that range. This is the one that I was thinking was weird. I don't know the length of that side, so I can't decide whether it's acute, right, or obtuse. So that's a weird one. Normally we would use Pythagorean Theorem to decide whether it's a right triangle or if it's an acute triangle, or if it was an obtuse triangle where c squared is so big that it's too big for Pythagorean Theorem. But this was weird, we were missing this side, so we couldn't do that.